Welcome to episode 7 of the Welding Codex. This is a podcast for those who want to learn more about the technical side of welding. We're going to talk about the philosophy of welding, welding codes, welding defects, metallurgy, and subjects that would bore the general population to tears. In this episode, welding engineer and CWIs Gary Pace and Peter Kinney continue their long, arduous journey into AWS D1.1 structural welding code, steel. This episode covers Part B of Clause 4 of 2015. I think it's Clause 6 in 2020. But it covers Part B, Welding Procedure Specification, Qualification. We're going to talk about essential variables, writing WPSs and PQRs, and the tables at the end of the chapter of Clause 4, 2015, Clause 6, 2020, and how to use them. Anyhow, thanks for joining us. Note, Pete and Garry are going to bounce back and forth between code editions 2015 and 2020 during the course of this episode. So beforehand, we apologize if the podcast gets a little off track or a little confusing in regards to he said, she said, 2015, 2020, who's on first, what's on second. All right, Pete, what do you think about 4.7, preparation of a WPS? Can I borrow a WPS from my buddy's company? Is that legal?
Sure, if you don't want to get caught. Each contractor has to make their own. There is some caveats where if you're ABC, big giant company, and you own multiple facets, that's a little different. But if you have company A and you have company B, company A can't borrow company B's welding procedures or PQRs. Everyone's got to have their own. A's got to qualify it, B's got to qualify it, C's got to qualify it. So you can't borrow your buddies.
Okay, I'm going to preface this next statement and give a definition. When I talk about a welding program, I don't mean the program that tracks WPSs, PQRs, and welding documentation. I mean a solid program. When you're talking about like a football program or a basketball program. To me, a welding program includes, how you're going to do things, your culture, your direction you're going to take in approaching everything, who's running what, who's your subject matter experts, who's your documentation people, who's your document control people, all of that kind of stuff. That is a welding program. I'm not talking about a piece of software that you punch in some numbers and it spits out a PQR for you or something like that. I am talking about a welding program, the overall organizational system that covers what you do in regards to welding and how you approach welding. All right, so you got to have, it gets back to having a welding program. You got to let the people that you're building stuff for know that you got grown-ups running the outfit. You kind of got to have a plan. So one of them is preparation of a WPS. You got to write down your WPSs, and that's covered in the code. 4.7 in 2015. I don't know what the numbering is in 2020.
6.7 in 2020.
Okay, it's like 6.7. All right, so then we go to essential variables. So essential variables is one of those terms that you're going to hear. If you're doing any kind of code work, essential variables is what you're going to hear and you're going to get beat up with. And you might as well just bite the bullet and learn what it is. And what do I need to address? So when you're writing a WPS, you need to address the essential variables in a code that are listed in the code. And sometimes you got to get the non-essential variables and the supplementary essential variables, depending on the situation. But in this code, 4.8, and it's 6.8 in the 2020 code, it gives us the processes. So if I qualify a weld procedure in shielded metal arc welding and I want to go to gas metal arc welding, I got a completely different set of variables, essential variables. And those variables are listed in table 4.5 and table 4.6. I think 4.6 is for when CVN impact testing is specified. And then we've got electro slag welding and electro gas welding, which aren't allowed under pre-qualified, but we can use those in a qualified situation where we're going to qualify them with some bends, some tensils, impacts, whatever. Pete, you want to walk us through those tables? What's your thought?
Sure. We have, like you said, as in a 4.5, and I'm not sure if it's 4.6 or 4.7 in the 2015. It's 6.5 and 6.7 in the 2020 code. And these tables lay out, table 6.5 lays out all the essential variables that you have to address. And when you have a change that means you got to requalify it. It's pretty easy. If you find your process up at the top and you just go down, if it's shaded out, that means it's not applicable. For example, changing of flux is not something that's readily available to the GMAW welding process. It's going to be grayed out. If it has an X in it, that means it would be applicable. All of these would have, if you changed the electrode diameter, it would be applicable for your welding process. And that table has all 5 that are generally used: SMAW, submerged arc, GMAW, flux core, FCAW, and GTAW. It has all 5 of those listed in this table. And the table, like I said, is pretty self-explanatory. The ones that really kind of seem to trip people up is a change in amperage, a change in voltage, a change in travel speed. And the reason those are a little difficult is you're given a range, plus or minus 10%, plus or minus 7, plus or minus 25, depending on, or 15 or 50, depending on the variable travel speed. How do you come up with, what is this value based on? Is it based on one pass? Is it based on an average of all the passes? That's something that the code is silent on, is how do you come up with a tolerance on that? Can you do it off the highest and off the lowest, or take an average of all 50 passes that you have in your PQR? There's different ways to do it. I'm not going to say there's one best way. Taking the average is definitely a very defendable and conservative, but it may also be a little too conservative an outlook. What are your thoughts on Gary, on how to take that percentage for WPS creation?
When back in the day, I had a coworker and we had a big argument about this, and he said you had to do it this way, and I said you had to do it this way, and we tore through all the codes and all the commentary and all the code cases, and basically AWS said, use your best judgment on how you're going to do the math on this. That's my interpretation, because I think they left it so ambiguous over the years that when people started looking into it and saying, well, is that 10% of the average, 10% of the high, 10% of the low? Is it, those numbers, where are they coming from? So any way you want to do that. But I think part of it gets back, no matter how you crunch those numbers, you're going to have to run with some kind of common sense. There's only so high you can jack those numbers up. So high you can increase like an amperage or a wire feed speed and be able to deposit sound weld metal. So there's multiple different ways that you can find those ranges for those essential variables, like travel speed, amperage, voltage, etc. I'm kind of the frame of mind where I do it and then I use my best judgment, as far as I probably go a 10% on my highest and 10% on my lowest on my PQRs, and I call it good. How about you, Pete? What's your theory?
Well, I've done it many ways. I've done it like that. What I find myself doing more is doing a scatter plot of all of my parameters and seeing how they fall, where you'll quickly see if you have a lot of outliers and all your numbers are basically jumbled in one area. That's how I tend to look at it. What I will also do is break it up into different layers, especially if you have a root pass or a hot pass. Those may be significantly different than all of your fills, and then your cap may be a little different. With a weld with a backer on it, you may not have as much difference between those layers as you would with, let's say, like an open root weld. But you still may start to see, you can see trends, and that's how I tend to try to look at it. Is there a trend for the first couple passes to be colder, and then they get hotter, and then base the tolerance, what, like I said, off of common sense. But what I found, the scatter plot usually produces, I will say, a slightly conservative parameter layout, but that's what I've been found that works for me, and is usually I rarely ever get any kind of pushback from a client on.
All right, so we're going to kind of loop back here and talk about when you're writing the WPS, if it's got a little X in there, you need to address it on that WPS. So for like gas metal arc and flux core, you've got listed here, is that a CC or a CV machine? You need to address that. If it's not on there, you need to address it. So how did we do this? Were we using constant voltage or constant current? It needs to be addressed because the deposition of the weld metal is going to be drastically different depending on what output you have, constant voltage or constant current. So however you're running it however you run it and qualify it, and what's listed on that PQR also needs to be listed on that WPS, and your guys in the field also need to be following that. It's like Pete was saying the other day with the constant, you throw a pipeliner on an old Lincoln buzz box and you're running in constant current output, and that's how you qualify the procedure. And then you go out in the field and then you've got a different machine and it's running in constant voltage. You can't cross the streams. You can't use the apples in the oranges pile and vice versa.
Correct. And I will say, if you look in the 2020 code, and I'm not exactly sure if it's like this in 2015, but there are some boxes that are neither grayed out nor have an X in them. I think that might be a printing error where they're in, let's say, the GTAW column for a change in mode of transfer. That's a lot of them are just white. I think that's an error. I think those should all be grayed out. That's my personal opinion.
So some of the hang-ups here, some of the ones that I've gigged people for in the past, stick welding's one of the one. A change in the position qualified, a change in the diameter or thickness or both not qualified by table 4.2, a change in the base metal or combination of base metals, and then you get down here to the omission and inclusion of backing or back gouging. If you qualify it with no back gouging or it's an open root and then you add backing, you're good to go. But you can't go the other way. You can't have a weld procedure that you qualify with back gouging and then you say, oh, we're going to do it open root now. It doesn't work that way.
You're right. Always look for the words omission.
And then we've got preheat, decrease of interpass temperature, and then the addition or deletion of post-weld heat treat. Those are, most of the time you're not going to get tripped up on post-weld heat treat, but just generally any weld procedure I write, I throw in there none.
Exactly.
The preheat temperature, you got to have that in there. And if there's a change in preheat temperature by more than 25 degrees, if there's a decrease from the preheat temperature. So if you qualify it at 200 degree preheat and you want to have the weld procedure run at 100 degrees, nope, you got to requalify it. And the same with the interpass temperature. On table 6.6, Pete, what do you got to say or to contribute to this conversation in regards to supplementary essential variable changes for CVN testing?
One thing I wanted to add, we were talking earlier about the little number, the big words giveth, the little words taketh. On that preheat and everything, there's a footnote E, and that E refers back to another section, which will then put us back to those big chart of materials. So you got to make sure you read. Always look for footnotes as well. So 4.6 in the 2015 is now 6.7 in the 2020 for PQR exception variables. In the D1 world, once you invoke CVNs, a lot more things become a shall, and you can't have as many changes. That's the biggest thing that you have. If you look basically at this table, there's like an X in almost every single box there is there. So it makes it more difficult to write a wide open procedure as soon as CVNs are invoked. That's kind of my biggest take on it.
And most of the CVN related work is going to happen in situations where it's a colder climate, Minnesota, Canada, Butte, Montana, whatever. I don't know. The engineer, though, is going to call out whether or not there's going to need to be CVN requirements invoked. But like Pete said, CVN requirements, there's a lot more X's in that table if those are invoked. If the engineer decides that you need impact testing on your WPS, PQR, it's going to get very messy pretty quick in that type of situation.
Yep.
Essential variables, 4.83, base metal qualification. You'll see in welding codes, AWS D1.1, ASME Section 9, a lot of times they'll have groupings of base materials. And they'll have groupings of base materials because for the most part, the stuff is pretty much the same. And I use the example of P1 materials or Group 1, your garden variety carbon steels. It's basically coat hanger. I know the metallurgists, well, they're not going to be listening, but if they were listening, I'm sure they'd send me and Pete some hate mail for me talking about their steels as coat hangers. But a lot of this stuff gets lumped together. So if you qualify one, you get another. So is there a table, Pete, that we can look at that would tell us what we get the most bang for our buck if we're qualifying weld procedures with one material to another?
There sure is. In 2015, it's table 4.8. 2020, it's 6.8. And it's listed materials or unlisted steels qualified by PQR. And it's a 2-column table where you have what you qualify on the left-hand side and what you get on the right-hand side. So for example, if you qualify any Group 1 steel to any Group 1 steel, you basically get exactly that, Group 1 to Group 1. When you qualify Group 2 to Group 2, you get quite a bit more. You get any Group 1 to 1, 2 to 2, or 2 to any Group 2 to any Group 2. And it builds as you go through. Where a lot of people get caught up is when you have an unlisted material. Any unlisted steel, either to itself or even to another steel that's listed in any of the groups, you only get that specific combination of steel that's listed in the PQR. For example, if you were welding 4130 to A36, and A36 is, let's say it's a Group 1 material in its thickness, you only get 4130 to A36. You don't get 4130 to A500 grade B. It's only the combination used in the PQR.
This table can be very useful in regards to qualification of welding procedures, especially on the shallower end of the pool, like Pete was saying. If you've got a Group 1 to any Group 1, you can qualify A36 to an A36, and you get everything that's Group 1 to Group 1, even if it's not A36. Or Group 2 to Group 2, if you had A36 that by thickness was Group 2, to A36 with a thickness, which is also a Group 2, you would get Group 2 to Group 2, Group 2 to Group 1, Group 1 to Group 1, any of those. So when you're qualifying your weld procedures, a lot of times it would behoove you to look at this and figure out, oh, I could do this and this to get the maximum bang for my buck, especially when you're doing welding qualifications. So this is an essential variable that you really need to look at and be cognizant of this table.
I agree, Gary. It's one that can trip people up. The other combination that is not listed, and it doesn't come up very often unless you're doing Sharpies, and you have that invoked as an essential variable. As you remember, we talked about table 6.7, and the first line item is a change in group number. And this is a common topic between welding engineers. It's different people have different opinions. If you were to qualify a Group 1 to a Group 2 steel, and you were to take Sharpies from both sides of the heat affected zone, what are you allowed? I'm of the agreement that if you test both sides, you're allowed Group 1 to Group 1, Group 2 to Group 2, assuming your tensils made the minimum for the Group 2 steels. But other people have different opinions. So if you're bidding a job and you assume that, you may be stuck where you may need to do 3 qualifications, Group 1 to Group 1, Group 2 to Group 2, and a Group 2 to a Group 1. I've been in that position before, so that's a caveat I want to make sure people know about.
Yeah, and a lot of times when you're bidding a job, if you don't have an extensive library of weld procedures, you probably want to throw in some money in regards to qualification, build that in somewhere.
So from essential variables, we go to Now we have methods of testing and acceptance criteria.
We're going to look at 4.9 in 2015, which is 6.10 in 2020. You want to run with this one, Pete? This is methods
Sure.
of testing, acceptance criteria for WPS qualification.
All right. So what we spoke about, touched on slightly earlier, is the visual inspection of the welds. All welds need to get a visual inspection at the basis, whether it's a PQR weld or a welder qualification or an operator qualification. All those need a visual inspection, and they have an acceptance criteria for it. Grooves and fillets, and then we go to a volumetric inspection, which is either RT or UT, and that would be applicable to your groove welds. We're not R2ing or UTing fillet welds there. Then we go to mechanical testing. We have bend tests. So we have 3 different kinds of bend tests. We have root, face, and side bend specimens. The root and face we do on thinner coupons, and side bend. Quarter. You're right. 1/4 inch, 3/8. 3/8 is the general cutoff between most codes, where we go from, or you can transfer from a root face to a side bend. The advantage of a side bend is it's a lot smaller of a test coupon. So if you got some kind of weird material, or you're testing on a pipe where you only have so much real estate, a side bend can save you a lot of room. That's the advantage of a side bend. And most of these tests are transverse to the weld. There are what's called longitudinal bend specimens. They're not used very often. The times that they are used are when you have an extreme dissimilarity between material A, maybe the weldment metal, and then material B. I don't think any of the materials in this code need longitudinal bend specimens. The only time I've really used these is when you are using materials that are extremely strong. Armor plating, you're going to be using longitudinal bend specimens, or at least looking at it. Non-post-weld heat treated 4130, 4140 kind of qualifications, you'll run into it. Things with very little elongation. They're uncommon specimens. And we have our acceptance for our bends, regardless of which bend it is. We have an 1/8 inch on the surface, a total of 3/8, 1/4 inch maximum quarter crack. That's common on all the acceptance criteria for the bends. Then we get into reduced section tension specimens. That's also very common amongst all your codes that you do 2 tensils. If you're doing something really thick, you do have the option to cut your specimens into thinner pieces. If you were welding up, let's say, a 4-inch thick piece, most test labs can't pull a 4-inch dog bone. It's beyond their machine capability, but you're allowed to slice them up. That's another not a real common occurrence, especially in the D1.1 world where 1 inch qualifies you unlimited thickness. So there's really no reason to qualify a 4-inch thick specimen unless required by contract documents.
So we've got reduced section, tension specimens.
We got the other ones that do exist is all weld metal, which to me I was going to say it exists, but it's not common. And then macros, and basically we use macros for PJPs and fillets. Other test that's commonly done is the macro etch test, and that's primarily just for PJP groove welds to determine weld size and fillet welds. That's pretty much where you'll see macro etch tests done in this spec. There is also an all-weld metal tension specimen, which is basically taken out of the center of a groove weld. It is not that common in the D1.1 world to pull those.
So those are some things that you might see, but not very often. Trying to explain, it's kind of like doing radio. We got to do sound effects or whatever, but a macro etch test is just you slice down through the weld, and then you use what's called an etchant, depending on what etchant you use on the material. But in the past, I've used like certain types of acid and some rubbing alcohol, and it gives you an idea of did you get enough penetration into the weld joint. And that's the direction you're going with a macro etch test. is to see if you're depositing sound weld metal, not a lot of defects, and you're burning into the base metal. That's the idea behind a macro etch test. It's like a proof test. All right, we can do this. We're doing good. We're burning in there. We're getting deep penetration, good fusion. Everything's going well. Okay, so a lot of times when you're doing these weld tests and you qualified a WPS or a PQR, you might have one of your tests fail. The code they've gotten written in there that, all right, we've got a situation where, let's say you had a bend fail or a tensile test fail. What are we going to do in that situation, Pete? What does the code let us do if one of our tests fails, a bend fails, or a tensile test fails? What can we do? Are we sunk, or is there a path forward?
There is a path forward, and it's a 2-for-1 for whatever failed test it was. Like in your example, if you failed a bend, you got to do two tests for that one. If you failed one tensile, you'd have to do 2 tensils. But it's if any one specimen. So if you failed 2, you're sunk.
So if you fail 1 and then you got to do 2, but like Pete said, if that second one fails, you're back to the drawing board. And if you're going to do if you're getting into this game as a new welding engineer, or you're the person that's going to be the qualification guy wherever you work, get used to things failing. It just is how this welding game is played. I don't know how many times I've had to go back to the drawing board and we re-weld it and put more post-weld heat treat, less post-weld heat treat, whatever. So, but it's part of the game, and they've got it written in where there's a mechanism. So, because a lot of times these tests will fail right on the borderline. Oh, it almost got to where I needed and it failed. So then, all right, I've got enough material. I can cut 2 more retests. They do that. I'm good to go. You mark it all down. You write up what you did, and then that you did a retest. All right, we're done with that.
Sure, we got CJP groove welds. There's some figures, 6.5, 6.7 in 2020. I'm assuming it's 4.5 through 4.7 in 2015. There is one sticky point, and it's came up only a few times, and this is on corner and T-joints. The corner and T-joint welds, you have to have the same corner or T-joint to be used in construction. It's a painful thing. I'm not exactly completely sure the history on it. I was hoping to find out at the next D1 meeting, but it was unfortunately canceled because of all this virus stuff we all have going around. But I will determine why that is, besides making it a little more difficult, kind of like a 6GR with a restrictor plate. That's an oddball one out there. Otherwise, you just go to the figures and you make your qualification groove weld. Not much else to add on there. You have anything more for CJPs, Gary?
No, CJPs are complete joint penetration welds, and they're generally a pretty clean qualification for the most part. A guy doesn't get tripped up in those most of the time. Unlike the partial joint penetration groove weld, these things can be a difficult animal to deal with. Pete, has there been any changes in how they addressed in 2020 the partial joint penetration groove welds?
There sure has been, Gary. This is where it's different than 2015. In 2020, there's a couple methods you can use. The use of a CJP groove weld, that's it. That's all you need. That's the first option. Second option is in the 2020 code, there are significant changes there, Gary. You can qualify it a handful of ways. The first 2 methods are basically identical, using a CJP groove weld, either using a listed or a non-listed joint detail. Really clean. You can qualify a PJP as a PJP. That's the other method. You can also use a flare groove weld to qualify it. I've never seen a flare groove weld used to qualify it. Those are the 4 methods on it. The first method, with the CJP, you get all of the PJP groove welds that can form the figure 5.2, which I believe used to be figure 3.2 in the 2015.
it's kicking you back and saying, if you qualify a complete joint penetration groove weld, you get all of the partial joint penetration groove welds that are listed in the pre-qualified tables, correct?
Correct.
So just as long as you qualify a complete joint penetration groove weld, and this is in 2020, then you can go back and cherry pick what kind of groove you want to use out of the pre-qualified weld joints that are listed in the tables of the pre-qualified section of the code. This used to get really messy in the 2015 version because then you'd have to do macro etches, and it had to do with cross sections and just all kinds of craziness. And I've asked a number of people, Pete and a couple other guys I worked with, I asked him one time about this 4.11.3 in the 2015 code, and I got 3 different answers from 3 different really good welding engineers that are really knowledgeable about this. So I think that's why the code committee went back and said, we're just gonna reboot this and just make some sense out of it so that it's not so damn confusing.
Correct. But it's been a complaint for many years. The other method, now this is when you use a CJP groove joint design that's not in figure 5.2, they still make you go back and do a test plate with the PJP and the 3 macros. So if you're going to do your CJP qualification, try to use one of the figures in the book. It makes life a lot easier. All right, for fillet weld qualification, they're much easier. You can do a T-test, which basically you have 2 plates that make up the letter T. One side you can do the largest single pass weld, and the other side you do your smallest multi-pass weld. And what that gives you is on your single pass fillet, it gives you that size and smaller, and on the multiple pass it gives you that size and larger. So what people will commonly do is a 5/16 and 5/16, or a 5/16 and a 3/8, with the 5/16 being single pass. That's a real common test sizes done. If you're using like 045 wire and bigger, that's easily capable by any of the wire fed processes. TIG welding, on the other hand, would be a little more difficult to get that. That'd probably be more like a 3/16, maybe 1/4 inch, and then probably a 1/4 inch on the multi-pass, maybe 5/16. But it's only 3 macros. That's all you have to do for the fillet weld qualification.
2015 on table 4.4. As we've said before multiple times, if you're going to be delving into these codes, you got to be able to find tables, and there's 5 or 6 of these that are used quite a bit. And if you're going to qualify fillet welds, table 4.4 is the one that you're going to use. And it's just 3 macro etches, and it gives you up to unlimited as far as the plate and pipe thickness, and then it tells you the max and the min sizes tested. So I'm pretty sure it's probably 6.4 in 2020, right, Pete?
You're correct.
Okay, that's a good place to break up the podcast into digestible portions. The original conversation was nearly 2 hours long between Pete and I, so I'm editing it and breaking it up into a few bite-sized pieces. That wraps up Part B, which covers WPSs, or Welding Procedure Specifications. Next episode will cover Part C, Performance Qualification, which is welders and how to qualify welders and the rules that we need to follow when we are qualifying welders. If you like these podcasts, stop by my website, texasweldingengineering.com, and go to the donation page. Also, if you're looking for CWI training at a reasonable price, check out train-eng.com. Also, if you're not familiar with my YouTube channel, there's a bunch of YouTube videos on there. If you just do a Google search under Garry, Pace, Welding, ASME, or AWS D1.1, there's a bunch of videos on there. Check those out too if you're interested. Thanks for listening. Hope this podcast was worth listening to. We're going to have more content coming out. Also, if you want to shoot me an email, gpacex@gmail.com. Give me some ideas, or maybe there's some questions that you'd like me and Pete or me and Joel to answer in regards to welding, welding codes, filler material, or any other material joining question that you might think we have a shot in hell of answering. Anyways, thanks for listening. Take care. Peace out.